Integrating blockchain and fog computing technologies can be designed differently for different applications. However, we do care in FoBSim about simulating two cases. The first case is presented in this figure where the blockchain is not deployed in the fog layer. This is very similar to non-fog enabled systems where users connect directly to the blockchain and write or read data depending on the access authentication scheme of the blockchain. However, fog nodes provide communication services, in this case, where users or things in the context of IoT send their tasks to their associated fog nodes, and then the fog nodes decide whether to process those tasks in the fog or simply send them to an agreed on blockchain system. Now, from there, we can find unlimited configuration options where tasks need to be anonymized or not, or whether smart contracts are used or not, etc. But nevertheless, end users might be aware or unaware of the blockchain integration since they require their tasks to be performed with low latency uh, or certain measures of security. So it depends on also the application level agreements and what exactly are the tasks performed. The second integration model is kind of more exciting where the blockchain is deployed in the fog layer. And here fog nodes wear two hats actually, performing tasks as both fog nodes and blockchain miners. The logical abstraction of the received task definitions can allow the fog to differentiate between blockchain and fog functionalities which can or need to be used for a given task. A simple example of this case is few fog nodes, each connected with several end users. Those fog nodes are connected to each other and they are privately collecting data from end users such that global analysis can be performed. Now, the data, according to the application layer, need to be saved in a standard way while it was not received in such a form. And accordingly, end users send their input data however they look to the fog nodes, and those fog nodes process and prepare data in a standard form and all agree to this data to be added to a unified ledger, which can in turn be read and understood publicly by any fog node. Later, all standardized data can be sent to the cloud, maybe for computing and analyzing on a global level. Now, several example applications can be given since the fog was initially proposed to solve the challenges in smart environments, which is a hot research topic nowadays. Yeah, to summarize, the fog provides cloud services while the blockchain provides other types of services, as can be seen in this figure. But we can actually map the two types of services to find a proper definition of services provided by a blockchain that is deployed in the fog. We have previously investigated available fog blockchain integration approaches in order to increase our knowledge on what exactly are the applications and configurations of fog blockchain integrated systems. We found that most of the studied systems deployed the proof of work, Byzantine fault tolerance, proof of stake, proof of authority, and proof of elapsed time algorithms, respectively, where the blockchain was mainly used for data storage and access control applications, mainly. We also found that the blockchain was deployed differently in different solutions. Some deployed it in the cloud, while others deployed it in the fog, and many other observations we have collected in order to know exactly what is needed and what are the configuration options when we integrate blockchain and fork technologies. The integration of blockchain in fog computing has advantages and disadvantages. Advantages include higher security, higher reliability, the immutability of the collected data, the openness. Usually, blockchain systems or solutions are open source, so users can see exactly how they work. Um, we don't need the TTP, but sometimes when we talk about fog-enabled systems, we do expect that we do have cloud virtual machines or cloud controllers. Maybe if we are using containers for web-based application, then we can have uh, gateways of the cloud that control the data flow throughout the system. The anonymity is the major um, let's say, advantage that can be proposed or can be used when we deploy blockchain. This is because majorly the identities of users are usually defined using cryptography, which uh, which is mainly like with the used schemes in blockchains. Usually, the cryptography systems used are much robust and almost impossible to be forged. Some disadvantages of deploying the blockchain include the energy consumption, the privacy issues, the latency, and you might ask, isn't privacy equal to anonymity? And the answer is actually no. Privacy is usually studied in or under four umbrellas. Um, one of which is the identity privacy, which is related to the anonymity. But we have other types of privacy like data privacy, location privacy, and users' patterns privacy by end users. And those four types of privacy together perform a disadvantage when, or I wouldn't say disadvantage, I would say it's a challenge to address privacy concerns when you deploy blockchain because basically the data is saved, as we said, on multiple nodes. So you need to be precise on the application definitions. The latency is always a disadvantage by blockchain, and we always say that if you don't really need blockchain to address security issues um, and distributed computing, um, then don't use the blockchain unless you have to use it. Otherwise, just use centralized solutions or maybe use a decentralized but with kind of controlled architecture with a trusted third party or with a server, let's say higher level controllers. And the challenges also include the standardization because we have a lot of blockchain integration with fog computing, uh, a lot of schemes, and basically we lack the standardization over several application domains of such integration, which actually results in a low level of trust in such integration, not only in blockchain but also in fog computing as a new concept, maybe studied on and researched for a few years now, but still it's not adopted widely in the market. That a lot of IT practitioners are not really aware of this concept. Mobility is usually solved by the fog, but when you deploy the blockchain in the fog, then it becomes a challenge to allow or disallow blockchain miners to handle mobility, whether you need it or not. And finally, in some countries, the blockchain solutions itself themselves are not legal. Like the blockchain technology in itself, sometimes in some countries are not legal, and you cannot use this technology for any application that you want, whether it was cryptocurrency or not. We have mainly identified four types of applications or application domains where blockchain and fog computing integration comes handy. We found data management is the most reason or purpose of deploying the blockchain. Reputation management systems also have utilized blockchain in order to enhance the latency and the security and reliability of a fog-enabled system. Distributed identity is related actually to the SSI models, or what we call the self-sovereign identity. I have a whole series about that in my channel. So this is a very interesting topic, and a lot of researchers working on that. So you can just go ahead and check the series, and it gives detailed information about self-sovereign identity and how to utilize blockchain to provide highly secure digital identity system.